All right, so we're finally done with the graphing, which was the most brutal part. Now let's go back a little bit to the algebra, to finding the domain of these types of graphs. So especially the last one. So we can see that secant, cosecant, tangent, and cotangent all had asymptotes. So we can find the equation of the asymptotes for any given trig function by figuring out the general form of the asymptotes. So here what I did is I made a cute little table of the trig function and then the equation of the asymptotes. Okay, so where the asymptotes appear. Here this k means k is any integer. So that means I can plug in k for like -1, 0, 1, 2, 3, any integer value, both positive, negative, right? I can plug it in and I will find an equation of asymptotes. Now we know that that's not going to be true if this is like 2x minus pi over 2 inside of the x argument. So we got to figure out, okay, if there's a period change and a phase shift, how is that going to change the asymptotes? So, one thing to really note is that finding the equation of the asymptotes is equivalent to finding the domain of the function. The only thing that will be different is that for the domain of the function, everything is just the same. It's just going to be written in set builder notation. And with a not equal sign. Okay, so that's the only thing that's gonna happen. So if I ask for the equation of the asymptotes, you'll have an equal sign. If I ask for the domain, you're gonna write the set builder notation with a not equal sign. All right, so how would you find the equation of the asymptotes if something was really complicated? So first we want to identify the trig function, so figure out which trig function this is. We're gonna look at the argument, whatever's inside the x value, and plug that thing into this x, solve for x, and the outcome will be the equation of the asymptotes. Okay, so it's actually a really easy process. One way that I remember them is that I can see that the c's, you see y equals cosecant and y equals cotangent, they have the same exact asymptotes, x equals pi k. And the ones I don't have that are very different from each other, they have the pi over 2 plus pi k. So that's a really good way to kind of just remember it. Okay, so let's go ahead and do an example. So again, for domain, use set builder notation with a not equal to sign. So let's find the equation of the asymptotes for this particular graph. Y equals 3 cosecant 2x minus pi over 2. So we know that the equation of the asymptotes for cosecant is going to be equal x equals pi k. That's what that guy's going to be. So what we're going to do is we're going to plug in the inside of cosecant, and I'm going to plug that in for x. So I'm going to have 2x minus pi over 2 equals pi k. So all I just did is I took the inside of the cosecant, plugged it into the x, and now what I'm going to do is I'm going to solve for x. So we have 2x minus pi over 2 equals pi k. Let's start off by adding pi over 2 over. So 2x equals pi over 2 plus pi k. And now finally, let's just divide by 2. So x equals pi over 4 plus pi over 2 k. This is going to be the equation of the asymptotes. Okay? If you actually wanted the domain, it'll be all values of x such that x is not equal to pi over 4 plus pi over 2k. This would be the domain. If I was to ask the domain, you will just have to have in the set builder notation form, which is basically x, a little line, and then here is where you will put the equation of asymptotes. With not equal sign. Alright, so now let's go ahead and do this next one. So y equals -100 cotangent of 3 pi x plus pi over 4 minus 4. Okay, so again, the equation of the asymptotes for cotangent is the same as cosecant. So x equals pi k. And now we're going to take the inside of the argument and plug it in for x. So we're going to have 3 pi x plus pi over 4 equals pi k. I'm going to subtract over the pi over 4. And we're going to have 3 pi x is equal to negative pi over 4 plus pi k. And now we're just going to divide by 3 pi. So x equals, what would this be? So the pi's cancel out, so I get negative 1 over 12 plus 1/3 k. This would be my equation of the asymptotes. All right, now let's do the last problem. Okay, so we need to figure out the equation of the asymptotes for a secant graph. So for secant, it'll be x equals pi over 2 plus pi k. We're going to take the argument 2x minus pi and plug it in here. So now let's add the pi over. So you get 2x is equal to, so this is going to be pi over 2 plus pi, that's going to give me 3 pi over 2 plus pi k. And now we're just going to divide this by 2. So x is equal to 3 pi over 4 plus pi over 2 k. All right. Feels so good to be back in the algebra realm. So yes, now that we're not graphing, it feels really nice. So finding the equation of the asymptotes isn't too bad. In the next video, I do want to do a problem where we actually want to find the equation of a function given some sort of graph. So we will do that one in the next video.